I wanted to talk about one more type of exponential function. Okay? And I wanted to talk about this f at x equals e to the x. Okay? A lot of people don't understand, and you may not remember from your pre-calculus class, where the number e comes from. All right? So one of the things let me do is kind of show you, or maybe remind you if your teacher didn't show this to you, just to make sure you understand that e is a constant. It's a real number, but it's a transcendental number. It's a non-algebraic number generated. All right. E is equal to 1 plus 1 over n to the nth power. Okay? As n keeps getting infinitely large. Okay? So we would say as n goes towards infinity. As a really neat exercise that unfortunately I won't do right here just because I don't have a calculator handy, what you might wish to do is throw in numbers like 100, 1,000, 10,000, 100,000, a million. And then in your calculator, go to e to the first. Okay? And then like I said, unfortunately I don't have a calculator that I can display, but we know that e is approximately 2.718 out forever. Okay? Go ahead in your calculator really quickly. You can pause it if you'd like to. Okay? And I want you guys to plug in, let's say, 1 million in for n, and see what number you get for that. Okay? So in other words, in your calculator, type in 1 plus 1 over 1, 0, 0, 0, 0, 0, 0. Okay, so that's 1 over a million. And then raised to the 1 millionth power. Okay. And then also in your calculator, after you've typed this in, type in e caret first, okay, or e to the first power. And what you'll see is that these two values are fairly close to one another. They're not going to be exactly the same. There's going to be some decimal discrepancy in there, all right? But what's going to happen is, as this number keeps getting bigger and bigger, it's going to get closer to this e to the first. Okay? So that's where the number e comes from. And again, a lot of students just think e is just some number that's magically fabricated by somebody ridiculously smart. It's not. It's a pretty tangible number that you guys can see works out. You may remember this structure right here. In fact, let me write it back over here. 1 plus 1 over the n to the nth power. Okay. You may remember from pre-calculus doing something called compounded interest. Okay. You might remember that if you have a specific amount, A, it's equal to whatever the principal is, times 1 plus R over N times NT. Okay. You might remember that from pre-calculus. You also might remember seeing this formula, A equals PERT. This first formula I wrote up here, okay? This is the amount that accrues in an account after some specific interval, okay, where n could be compounded monthly, daily, hourly, even quarterly. Right? This one is continuous compounded. In other words, the number of compoundings becomes infinite. So these two formulas are really the same. It's just that n approaches infinity to get from here to here. So to go from here to here, n would approach infinity. Now, I'm not going to test you guys on anything like that. I'm just trying to make sure that you guys understand that the number e really does have some specific instances to where it's utilized, and it comes directly from this formula. Okay? What you may wish to do is, when you're graphing calculator, go ahead and graph the natural exponential function. I'm going to erase all this stuff. And in your graphing calculator, You don't need a table of values for this one, but if you wanted to, you certainly could. Go ahead and graph the function f at x is equal to e to the x. So you would go in, you'd hit your y equals button, and then from there, you would just type in your e caret x. I bet you're going to get something that looks pretty familiar. I bet you're going to get that the function looks something like this. Okay. Your window might scale it a little bit differently. Okay, that's fine. Okay. Again, I just do it by hand here. And what you'll see is that it looks almost identical to the functions that we graphed earlier. Remember, we did the 2 to the x, we did the 1/3 to the x, except the 1/3 was flipped around. If I asked you the domain for this thing, you would tell me the domain is all real numbers, or in other words, minus infinity to positive infinity. If I asked you for the range, again, it looks like it's not going to dip below the x-axis. So the range would be from 0 to infinity, and if I asked for an asymptote, you would tell me y equals 0, because once again, it tries to reach that axis, the x-axis, but it never dips below that axis. So natural exponential base, or the natural exponential function, is just something that you already know. It's just a big old calculator operation that the calculator just generates very quickly. And you guys can see that it has some application. I'm sure you've seen the amount PERT before, which is the same as the compounded interest, which hopefully you've seen before. Again, if not, no big deal. I just want to make sure that you guys know what the natural exponential base is and that it is a tangible value. And it's just a big old exponential function that we're used to.